All right, I thought I would record a video while I'm grading your lab. That way you can have feedback if you feel like you want to watch the video. And speaking of watching the video, if you're watching this video, if you look at the bottom right of the screen on YouTube, there's a little gear icon. You can click that and change the speed. I recommend speeding me up because I will be looking at your lab for the first time and grading it. And sometimes that might take a while. So there might be, there's no need for you to sit through this in real time. So again, feel free to fast forward this. Another thing I want to mention too before I get started is if at the end of this video you still have questions or would like some more feedback, let me know. I'd be glad to help you. And also, if you allow me to share this video or at least change the setting from unlisted to public, then I give you some extra credit. So shoot me an email at the end of this video if you will allow me to grade it. And I also, sorry, you'll notice I'm a little bit distracted. I am working from home right now. I just received a text. And also my son should be coming home within the next 10 minutes. So hopefully I can knock this out before then. Otherwise, please forgive the interruption. But that being said, let me try to get through this quickly. So I will apologize for doing it quickly. But again, I'm kind of in a rush here. So let's look at what we're dealing with. So you're thinking overall the non-renewable has increased. You think natural gas has increased. You think coal has decreased. You think nuclear has increased. Pump storage decreased. Petroleum increased. Other gas increased. Natural gas will be the highest increase. Coal being the highest or the largest decrease, and you think renewable energy saw a larger increase than non-renewable. All right, let's see if your predictions are correct. Let's go look at the table. Now, you did lose points here. This is actually very important because I need to know what years you used so I could look back on the data. It just so happens that the people, let's stick with that, right? So I need to know what years. So now I'm gonna have to pull this up. And again, that'll take a little longer. I apologize. But this is why it was important for you to put the years. So now I'm gonna pull the website up so I can compare your data to the data on the website. I should also point out that you are the second person to do this version of the lab as opposed to the other one. So I've graded a lot of the other ones, so I'm a little bit less familiar with this version. So let me just take a look here. Here we go. Again, I don't know what years you're working with, but I can spend a little effort and time and try to figure it out. So natural gas at about 1400. What year was that? Natural gas, 1400. Yeah, there it is. 1476.6. And I'm going to skip, just look at the first year and the last year, because as far as trends are considered, I'm not even concerned about the middle year, right? We don't even use that for our calculations. But anyway, so the most recent year, they're calling that 1691. 1600 good. So coal, we're going from about 890 to about 670. 890 to about 670. That looks good. Nuclear from about 780 to 775, about, right? Nuclear from 787. That looks good. Pumped hydro storage. This one, I was mentioning this on the other video I made for one of your classmates. I don't even know how to decipher this, to be honest. This is nothing you did. I don't understand what they mean by having a negative pumped hydro storage produce negative energy. I'm going to look into that when I get a chance. And if you want to, feel free to write a paper about it and explain to me what it means, because I really don't know. And I would do exactly what you do. Well, I'd assume what you would do, which is Google it. So I will eventually. But again, I leave that open to you too. If you want to write a paper, it could be a really short paper, like 1 or 2 sentences. You might look it up and find a source that gives you exactly what you're looking for, and you can maybe explain it in a couple of sentences, or you could write a couple of pages, whatever you want. Obviously, the longer it is, the more it's worth. But anyway, let's move forward. Petroleum, we're talking about 18.3 to about 16.9, 16.8. Petroleum, 18.3, so that looks good. Other gases, we'll call it about 3.3 to 3.2. Other gases, 3.3 to 3.2, that looks good. Renewable total, There, that's a mistake. All right, so renewable total should be this, right? Renewable should be 785, 870, and 867, right? That's the data you need right there. So that will all be wrong. And technically, I don't know how to do this. On one hand, this math is incorrect, right? Because what we have is a negative difference, right? Is going down. That means this should be negative 14%, assuming the math itself is right. It should be negative, not positive. However, again, like I mentioned, this is actually a mistake. And if you look, renewable has gone, like I said, from about 780 to 860, right? So renewable has actually increased. So it's a weird situation. That's not why you're losing any points for this, is because the fact that you have a positive 14 in all actuality is probably correct because it is positive. Meanwhile, according to this math, it should be negative. So weird situation. I'm just not going to deduct points. Renewable totals. Let's see. Excuse me, non-renewable totals would be, let's see. Let me show you how to figure that out. Looks like you may have figured it out already. So we have about 3,900 minus about 780, right? So 32, that looks about right. 3,200, yep. And then we have 3152. So 418 minus 867, 41, 31. Yeah, that looks about right. So a change of negative 100, about 3%. Yeah, that looks all right. Except this, again, to deduct a point, because that's supposed to be negative, right? That's a negative change. There was not a 3% increase in non-renewables. There was a 3% decrease. Same with this. And same with this one. Same with this one and this one, 10, 11. So, whoops. First of all, let me make sure I'm doing my math correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, that's correct. Now let me write down some information for me so I don't have to go back and forth. We're saying the ones that saw the decrease are coal, nuclear, pumped hydro, and also before I go to the next page, I do want to point something out. What we're looking at here is, you know what? No, I'll just leave that at that. No need to muddy the waters. Anyway, so petroleum also saw a decrease. Other gases also saw a decrease, so that should be negative. Other. And yeah, that's it. Oh, yeah, and then non-renewable. Okay, non-renewable also saw a decrease. All right. What was your hypothesis and was it correct? Overall, so this is a three-part question. You have to repeat your hypothesis. I know that seems redundant, but it's on purpose. Students very often lack the ability to look back and compare their data to their hypothesis and see if it's correct or not. And there's a three-part process to that. One, you've got to look and see what your hypothesis is. Two, you have to compare it to your data. So again, that's why this is a three-part question. So at the very least, at the very least, you lost points for not repeating it. Well, hold on. Let me not get ahead of myself. So overall, non-renewables, it decreased, so you were incorrect. All right. So again, it did decrease, so you were incorrect. So you're going to lose half a point because you didn't repeat your hypothesis. And again, I know that seems redundant, but it is important. It really is. It's a habit that you guys should be in. Anyway, let's move forward. It increased. I was correct. In this case, I guess I won't deduct a point because in this case, it would, truly, truly be redundant. So if you were correct, obviously, then your hypothesis was that natural gas would increase, right? So I'll allow that, so to speak. Next one. It decreased. You were correct. Okay. Again, since your hypothesis was correct, I'm not going to be picky. I'm not going to take a point away for that. It decreased. I was incorrect. So put an X there because, again, you needed to repeat your hypothesis. So half a point. Let's see. We've already talked about coal. I just talked about nuclear. Hydro, it decreased. I was correct. Yeah, I'll allow that. That was a really odd one. So I'm not even going to address that one because it's not odd on your end. It's odd on the end of the website. All right, sorry about that. Anyway, back at it. Hydro again. I don't want to address hydro because it was such weird data. I don't even know where to start with that. Anyway, the petroleum, it decreased, so you were incorrect. Petroleum did decrease. However, again, half a point because you didn't repeat your hypothesis. Excuse me. Other gases, it decreased. You were incorrect. Other gases did decrease, but again, half a point for not repeating your hypothesis. Move forward. You were correct. It was natural gas. That is the one that saw the largest increase. Off the top of my head, that sounds correct. Let me double check. Natural gas went up 15%. Seeing, yeah, anyway, just leave it at that. Yeah, 15%. Obviously, if you strictly look at the percent change column and didn't realize that you made math errors, then you would say nuclear had the largest increase, right? Because that's a positive 53. But again, as I mentioned earlier, that should be negative. But anyway, so we're dealing with 15% increase there. What else are we working with? Yep, that's it. So good. Correct. Correct, it was natural gas. You were correct. It was coal. Again, let me take another look and be sure. Coal went down by 25%. So no, look, nuclear went down by 53%, right? So according to your math, it went down by 53%, right? So that's another one missed. I will point this out though. And again, like I said, I don't like to pull out a calculator and double check everybody's math, but I can look at this and see now that there is a big error regardless, because we're going from about, let's call that 800, right? So we started at 800. Now, if we call it a 50% decrease, right? I'm just ballparking here, but if you went down by 50%, right? We started at 800, right? What's 50% of 800? That's 400, right? So if you took 400 away from 800, you'd be left with 400. So if we went from about 800 to about 400, then yes, that would be a 53%, right? So again, your math is wrong there. In this case, not just because it's positive when it needs to be negative, but also because the math itself, the calculations were incorrect. Anyway, that being said, I'm still holding you accountable for what's in your table, and according to your table, nuclear saw a larger decrease than coal. So again, nuclear saw a bigger decrease than coal, according to what you wrote, according to your table. So there we go. What was your hypothesis? Was it correct or incorrect? Larger increase, non-renewable. I was incorrect. So again, in this case, yeah, full point, because it was actually renewable that had the larger increase. Right? And I know that seems, I know I'm being a little bit slightly, I hate to use the word unfair because it's not unfair. It's tricky, right? On one hand, you got something wrong because I'm holding you accountable for the data that you actually created. That's the last thing we talked about. But on this one, actually, no, even according to this one, even according to your own, excuse me, let me back up. Even according to your own data, renewable is plus 14, while non-renewable is plus 3, right? So even though your math was wrong, renewable actually did see the larger increase, not just in reality, but even according to your own table. So that's why you lost a point for that. Anyway, why do you think so again, the one that saw the largest increase, why do you think it saw the largest increase, right? Why did natural gas increase more than the rest of it? What is something about it that's unique than the other non-renewable sources? Natural gas was the new abundant resource when coal was shut down. Well, coal first. It's important to note that natural gas is it's not new. It is relatively new, and coal also hasn't been shut down. It's just been regulated, but so is natural gas. Um, yeah. So the idea here is like, so basically, you just repeated, and this is kind of an issue I've had with other students. You just kind of explain the situation, right? So I've already said, hey, natural gas, it increased the most. Why? What is it about natural gas? But you just kind of repeated what I said, which is that natural gas was used more than coal, right? And amongst others, right? So you need to come up with a reason. What is it about natural gas that makes it increase more than the rest, right? Something unique about it. So, for example, if it was coal that saw the largest increase, you could put, I think it was coal saw the largest increase because it's the easiest to get to. And that's not true, but you can make that assumption. And another reason you would have lost a point anyway is this right here. You can guess or you can look it up, but you need to let me know which, right? So in your case, I don't know if it was a guess or not, but either way, again, you need to come up with an answer, something that's unique to natural gas. And the opposite is true here, right? So now we're talking about the one that saw the biggest decrease. What is unique about coal that made it see the largest decrease? And let's see what you had to say. Coal is a decrease because the coal mines have been shut down in a lot of places. Again, that's just kind of repeating it. That's like saying, and I use the example, and if you look at the lab worksheet, I leave comments in the instructions, and it says the example I use is something like shoes, right? So if I said last year, the purchasing of running shoes decreased more than any other type of running shoes. What is it about running shoes that caused it to decrease more than the rest, right? So now, again, I'm using a non-biology example. Like why did running shoes see the largest decrease? And this, the way you answered it, would be like saying, running shoes saw such a decrease because they've been shutting down a lot of running shoes factories. But that's kind of hand in hand, right? So that's like cause and effect is what I'm saying, right? So what is causing the coal mines to be shut down? You see what I'm saying? I hope so. If not, let me know. Anyway, let's move forward. If the overall consumption of non-renewable energy, so this is asking the big picture stuff, right? Are we using more energy overall? Are we using more renewable energy overall? Are we using more non-renewable, and more importantly, why? And again, this is a guess. It's okay to guess. I just want to know. This is a thinking question. As long as your answer is addressing the question, you're most likely not going to miss it. Let's see what you had to say. I think it is because we have such a high and growing population that renewable energy cannot keep up, so we're continuing to use non-renewable energy. All right, I hate to do this. Like I said, normally you wouldn't miss it, but the problem here is you have a statement that is factually incorrect, right? So you know what? I won't even do that. You could argue that. But according to your data, right, according to the data in this lab, we do know that renewable energy is actually increasing, right? It's not decreasing. So yes, it not only can it keep up, but it is keeping up. But nonetheless, we'll move forward. Why do you think you were required to analyze? All right, so basically this is saying why multiple years, why not just 1 year? Let's see what you said, so we can see the increase and decrease. Good, right? We want to see change. It's more data, right? So let me use this example. If we were to just look at, I don't know, this year, 2023, and I said, what is the most popular source of non-renewable energy? You would look and you would properly say natural gas. Actually, this is a bad example because not only is natural gas the most popular according to your data, but it is the one that is increasing the most too. So anyway, let's move forward. Let's see, increase and decrease. Yeah, very good. Now let's take a look at your graph. The graph has been historically really tough for your classmates. Let's see how you did. Use of energy, percent change. Once again, I say this once again for you and for your classmates. Energy usage. What you're losing the point for is that you are not. This point is because your title, at the very least, should indicate which years. Because if we're doing percent change, we need to know from when to when. Right? That's why you lost a point. Some other things that would help your graph, but I'm not deducting points for, is if you said use of change, use of energy. I mean, how would I put it? Well, actually, I don't want to give it away, but it should also mention the fact that we're talking about kilowatt hours, right? We're talking about percent change. We see that it's a percent change, but a change in what? Kilowatt hours or cost or the number of households using that particular energy source or the number of people employed in that particular energy sector, right? There's so many things it could be. So your graph title would be improved if you also included that this percent change is about kilowatt hours. But again, I'm not going to deduct a point for that. I will mention this though, because your table was incorrect, you also have some incorrect bars, right? Because some of these should be negative percent changes, not positive. For example, again, I've said this, maybe not to you, but I've said it a lot throughout the semester. A graph should tell the story of your data. Somebody should be able to look at your graph by itself, right, without the rest of the lab, and be able to see what you're trying to say, right? They should get a good grasp of what you figured out. And if I were to look at this graph, other than things I've already said about not knowing from what year to what year, and knowing that we're talking about kilowatt hours, billions of kilowatt hours, I would look at this graph and be like, wow, look at this. Nuclear, man, it's really up and coming. Right? If you look at that, by far, nuclear has such a positive change compared to the rest of them based on your graph. But what we know from looking at the actual data is that's not the case, right? So I suggest to you and anybody watching this video, take a step back. When when you're done with your graph, take a step back. Maybe even show it to somebody and ask them, does this make sense to you? Tell me what this says, right? And you could ask them, like, which energy source do you think is seeing the greatest increase? And again, naturally, somebody probably say, oh, nuclear is seeing the biggest and other gases is seeing the smallest. And then you could compare that to your actual data and see that that's not correct. Anyway, let's look at this. I hate to do this too, but this is free points. Save the file as a PDF before you upload it, right? I hate to be picky, but there's reasons for it. I could get into it if you want. Send me an email. I'll explain it. We can meet online, but it's slightly important, but even if it wasn't, it's a free point, right? If you do it, it's a free point. So yeah, it's just to save it as a PDF. I guess while I have this recording going, I might as well show you how really, really quickly. It's pretty simple. If you're pulling up a document, let's assume this is your copy, right? You've already gone through this whole thing, a file, make yourself a copy. All right, there's your lab. Now, when you're done with the lab, you need to download it. So when you download it, go to File, Download, instead of as a Microsoft Word, do it as a PDF, right? That's it. And I will mention this too. And this doesn't say anything about you. I don't know. We're at the end of the semester. This may be the first time you made that small mistake, and it is a small mistake. But I do want to point this out to you and hopefully anybody else watching this video. A lot of the mistakes I see in this course are not even biology mistakes, right? This is like big picture, attention to detail, paying attention to what you're doing kind of mistakes, right? So this, again, attention to detail would have prevented that mistake. And here, looking at the big picture, you just look at that graph and like, wait a minute, this is not what I looked at when I looked at the website, right? It's a big picture stuff. And this stuff right here, again, for the hypothesis questions, that said, what was your hypothesis, right? And you didn't repeat it. And I'm not like saying this as in, trying to put you down or anything. It's a common mistake. A lot of people make it, but that's what I'm trying to get at too. Not just teach you biology, but get you looking at attention to detail and the big picture. And going back to this stuff, right? We're looking at this table. I mean, these should be negatives, right? We went down a lot. That should be a negative. This went down a lot. This should be negative. And additionally, and I'll get off the soapbox here in a second once I'm done with that, not only is that something that you should just get, right? You should be able to look at it like, oh, that doesn't look right. This should be negative. Not only that, but if we pull up the original document, you'll see that I give instructions on how to do that, right? It literally says, this is how you do it. It shows you that formula. Of course, that was a positive, right? So then I have examples too. And I made sure that both of the examples, I had one that was a positive change and one that was a negative change. And you can see the negative, it's in the percent change as well. It's not just in the difference. And also, once again, I showed the students how to do the math. Anyway, that's it. I'm gonna get off that soapbox. There we go. I think everything's accounted for. Let me just double check the math really quickly. And I apologize, I'm making you wait for this, but again, feel free to speed this video up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, shoot, those were halves. I just have to trust my math. I don't want to waste your time or my time doing that because, and let me end it on this note, as always, you can still turn this in, resubmit it with corrections, right? So feel free to resubmit. Your grade, which I'm about to calculate, is going to look a lot worse than it is because you did miss a lot of points for the small mistake of not repeating your hypothesis. So again, feel free to redo that. Anyway, let me check to see if you did any extra credit. There's none there, so let me do the math, and I'll pull the calculator up so you can see the math. There's a total of 39, right? That's what we're dealing with. And you missed 19, so minus 19. That means you got 20 out of 39, so 20 divided by 39, which means you got about 51% correct. Multiply that by the points possible, which is 25, and that gives you a 12.82, right? You earned 12.82. And again, just small mistakes. Overall, despite what your grade shows, I think you did a great job. You just made the math mistakes on the table, which then threw you off later. And those mistakes are easy to make. And then again, you failed to repeat your hypotheses in some of those questions, which again are easy mistakes to make. But overall, you did good. I feel like you mostly understood what was going on. So feel free to resubmit this with corrections. If you have any questions, let me know. And once again, if you will allow me to change the setting from unlisted to public, then send me an email and I'll give you some extra credit for that. And that's it. Thank you for your time.